Welcome to this session of Workforce Reimagined. My guests today are Brad Baker, the co-founder and chief technology officer of CTG Federal, and Mosa Imamjome, the executive director of engineering, also at CTG Federal. Mosa, let me talk a little bit about AI. It's everywhere. As you heard me talk a little bit about, GSA is using it a lot, every agency's. We know that it's the latest shiny object, but why are we so excited about it? What has changed over the last couple of years? Give me a little bit of history side.
Yeah, so most people are familiar with, in 2023, OpenAI came out with the ChatGPT model. It blew up. Everyone started using it, your grandmother, your kids, everyone. But if you go back to 2017, there was a paper came in that revolutionized AI. It was called Attention is All You Need. And basically what they said was everything we had done with AI and machine learning in the past is all wrong. The way you need to do it is to focus on keywords for the attention and give those words attention, meaning more compute cycles and more intent or more weight for the answer. And it actually was correct. What they theorized was the way that, or was called the transformer model, which is what all of these large language models are based on today. So Anthropic, OpenAI, Google, Gemini, all of those are based on this transformer model, which not only increased the accuracy of the large language models, but it also decreased the amount of compute power required to run those, which I know sounds kind of crazy because we're going to talk about how much compute power is actually required to run these models. But that paper really is what cemented AI and made possible where we are today.
A lot of folks love to look back at 2023 and the ChatGPT when they released their big LLM and their big, but you're pushing this back even further, well before 2023, because AI seemed to, this concept of that inputs and inputs, give me an example if you can think of one, like how do I plan my vacation? That's the input?
That's the input, yeah. And so when we look back, AI and machine learning has been around for a long time. Its foundations have been in statistics, and they've had a lot of these different models that required a lot of compute. They were slow. They weren't always super accurate. But this paper, that Attention is All You Need, and the transformer model changed things where you could actually get much better performance with fewer compute nodes or GPUs. So the hyperscalers came out with massive amounts of compute that are now available for us. And so we could take these models and scale them exponentially. And so in 2023, OpenAI did that and came out with their ChatGPT that has exploded in use. And so you can take any sort of sentence and plug it into the computer, and it could be a question, it could be a command, it could be an algorithm, it could be in a different language, and the model can then ingest that and then come up with an output that has gotten more accurate over time. They have now reasoning and thinking models that allow it to spin off and do some internal calculations to figure out what the best output would be.
I think it's really important for us to recognize that there are a lot of closed source models and open source models. So Meta put out Llama, Mistral, there's a few others that are out there that are going to be able to be used in federal data centers and classified spaces. So we don't have to think that, hey, OpenAI is the only way to go, or Claude from Anthropic is the only way to go.
Mm-hmm. There's a lot of agencies who are starting to build their own. I know GSA, I was just heard from their chief data and AI officer recently, and he talked about a model they built. I know the intel agencies. I just want to go back to something that Mosa was saying around cloud, and maybe Brad, this idea that the cloud has advanced further enough along that, it can support these models. Because previously, as Mosa was saying, it probably was only done in high performance computing centers and places like national labs who had enough of the power, right?
Mm-hmm. Yeah, so what we've seen is back in the day, we used to call them data centers, and now Jensen at NVIDIA is calling them AI factories. And Google and some of these other cloud providers have built their own chips to really expand in the AI realm. And so what we've seen is an explosion of these technologies and the use of the OCP framework, where folks can leverage multiple OEMs and ODMs, original design manufacturers, for their specific use cases and apply it to theirs. And so what we're seeing is it's not only the big 7 now, we have a bunch of other small CSPs and MSPs.
Right, you said 3 letters that people may not be familiar with, OCP. I had to look it up myself. I know Open Compute Project.
Yes, sir.
Did I get it right? There we go. So let's talk about that. What is it? How does it work? Mosa, you want to lead us off?
Yeah, I'll start off. So the Open Compute Project was born out of Facebook. They wanted a way to come up with new hardware faster, more efficiently, and more cost effective because they're building out these massive data centers. And I think Brad can give us a little more details.
Yeah, so basically what happened is they didn't want to be beholden to the big OEMs and the profits that they were making, and so they wanted to farm it out to multiple ODMs, original design manufacturers. And so they owned the actual design for the motherboards to the power supply. And if you remember back in the days when Google was first started, they literally put like motorcycle batteries in each server and because they're like, hey, we got to make this modular and fast.
So OCP, is this something that's relatively new, going back to 2017, or has it been around for some time, but it's really getting attention because of this shiny object AI? People are very excited about it.
No, it's been around for quite a while. So 2011, I think, is probably when it was founded. It really caught up steam in 2017, 2018, where a lot of the cloud hyperscalers were like, hey, we don't want to buy these specific systems anymore. They started to design their own control planes, that sort of thing, where they had their specific security things. So like AWS and Google, they have their own security plane that iDRAC or something on Dell might not necessarily have to the extent that AWS has.
And it's important for people to know they've probably seen OCP today in some form in their standard servers. A lot of times they'll include an OCP card for their network communication. So it's a technology that's been around for a while. It's integrated into existing systems, and then there are entirely new designs for the servers as well as the racks that contain these servers as well.
So why should federal agencies care? It sounds like something the hardware people can take care of. I'm going to buy it from somebody. They'll OCP me to death, and I don't have to worry about it. Why is this important for federal agencies and people to know about as they continue to kind of move deeper into AI?
So, AI, unlike many other technologies, has a barrier to entry that is the hardware. In the past, new developers had made software that you can download, run on any type of hardware. But to effectively run these models, you need to have specific hardware configurations and a lot of it if you want to scale. And so why it's important for the federal agencies to look into this is they can now standardize on a design and procure large amounts of compute in what we would call scalable units. So they can get a rack of 72 servers delivered and shipped within a specific design frame, and be able to scale out rapidly. Whereas before, maybe they're getting power supplies and PDUs from different manufacturers and racks and servers and integrating everything. But fast forward to today, we could now have a DC bus bar in the back of the server with all the I/O in the front. So you pop in a sled, push it in, makes all the connections in the back, and it's ready to go.
Yeah, I think it's important to say that a lot of the OEMs are definitely contributing to the OCP project. So, Dell is a big supporter of this, HP, Supermicro, and there's all the different ODMs, and there's some specific to the United States that we're really excited about as well.
Yeah.
So this is a framework, so this is a set of standards. This is something where, okay, if you're going to use AI, here's some best practices to keep in mind as you're buying hardware to support it. That's what OCP is, and I'm trying to bring it to a low level.
Right.
Or correct me.
And it wouldn't be specifically for AI. It could be for any, it's existed for a long time before AI models became popular as a way to grow these hyperscalers, as a way to design and get a server within spec at a low cost and be able to ship and deliver those.
We like to think of it about rack scale computing, and this is what a lot of the federal government is really pushed towards the cloud for a long time, and now they're saying like, hey, that's actually really expensive. We're renting the cloud. Why don't we still have our data center? We can still own our own rack scale compute. So it can be from compute, it can be storage, it can be AI centric hardware.
A lot of agencies, when I talk to CIOs these days, there's this kind of we're excited about the cloud. We're still moving there, but we know not everything can move there. We need some data centers. Is that what you're finding among your clients as you're talking to them? Are they still in that, hey, the hybrid world, which we've been talking about now for a decade, it's more of a reality because, to your point, well, I thought the cloud would save me money. Okay, I'm not really saving money. Oh, I thought the cloud would be more secure. Well, it is more secure most of the time, except for when it's not. What are you hearing from your government clients?
Yeah, for the most part, our clients are saying like, hey, I just invested $500 million into the cloud over 5 years.
You got some really big clients, by the way.
Yeah.
500 million.
Yeah.
Go ahead, sorry.
Yeah. NASA.
NASA, there you go.
Okay. Yeah. And then they've realized like, oh my gosh, I blew through my budget too fast, and so now they're repatriating some of the workloads because it makes sense in our frame of mind is to test in the cloud. Hey, let's see if it works. If it's cloud native, let's do that. However, if you're going to want to run some of these AI models on-prem, you want to do like a chatbot, ChatGPT for my data. I want to do that on-premise. You don't want to run that in the cloud because the egress fees are going to be tremendous.
It goes back to that cloud paradox. Andreessen Horowitz did a great job. They released a blog about this where you're crazy if you don't start in the cloud, but then you're crazy if you continue to stay in the cloud as you grow. So, finding that sweet spot for you and finding the mission cases or use cases that make sense for the cloud is imperative for our customers.
My sense is a lot of agencies are starting to find that sweet spot, right? I mean, you see it with DoD, with fit for purpose cloud and really general use cloud, but they're also saying, but we have these things at DISA Dex and other things. As agencies kind of continue this modernization journey and really start to lean into AI, how do they find that right balance? I mean, what kind of advice can you give? Because again, traditional servers are going to continue, the cloud's going to continue, and there has to be some sort of I know I said hybrid earlier, the hybrid world, how to live in it and then apply the OCP stuff. I
think this is perfect for you to talk about your, I like to call them t-shirt sizes and the scalable units.
Yeah, so, we talked a lot about the compute required for these AI models, but really what differentiates them, because a lot of these AI models are open source, anyone can run them, but the type of data that you feed it and the data that you have is really where you're going to start defining the value for you. And so having massive amounts of data sitting in the cloud, you can't turn it off. You're constantly consuming storage costs there. So it makes sense to decouple that and move these models on-prem. And so what we've done at CTG is we've created t-shirt sizes for small, medium, large, even for entry level, to be able to start running these models, start investigating, am I going to look at some AI vision? Am I going to do some natural language processing? Depending on what it is, we've got a size that's right for you. And a lot of cases, some of these customers don't know what they're going to do yet. And so we've got an entry level that's a very low cost system. We can deploy it on-prem and you can start running these models because, as I mentioned before, the barrier to entry is that hardware. If you don't have these GPUs and if you don't have the hardware that's able to run these models, you're left behind.
One thing I think is really important is that a lot of the federal agencies, and we've found this in several, can't talk about specifics, but they would download these open source models and just start running it on a laptop or a GPU cluster, and you're like, guys, time out. Do you have guardrails associated? Do you have you tested it to jailbreak it to try to get it to tell you some of the data that you fed it to make sure that you secure the enclave of the data that you've got?
I know there's a lot of people saying, oh, let's create the sandbox, let's make it offline, to test out the models, but I imagine there's also some on the other side. And most I have to say, I love the t-shirt example. I'm so glad you didn't say the crawl, walk, run example. That gets overused, but I imagine it's the type of thing too where, let's start with the small, right? Mm-hmm. We'll do a small, let's see how it works. Okay, well, look, we're finding some success. We see that we got to move to the medium, to the large, extra large, double X, triple X, go on and so on and so forth. What are some of those use cases that are standing out to you from agencies these days? What are they asking from you in terms of, hey, we want to use it for chatbots? A great example. I'm hearing a lot about that.
Yeah, well, so these chatbots, they're probably the most valuable thing to agencies right now with these large language models. and what we'd call RAG, or retrieval augmented generation, where we can inject the agency-specific data, whatever that happens to be. And the use case could be around HR, it could be accounting, it could be an employee handbook, whatever it may be. But we can inject that into the model, so when the model is asked the question, it will look back into its database to see what relevant documents might have an answer to that question, and it will reply saying, this is the answer based on these source documents. You can double check and read through those on your own. But as Brad mentioned, you need to have guardrails in there. So depending on the use case, you may not want the chatbot to answer a question using data that user doesn't have access to. So it's really important for agencies to start thinking about how are we going to customize and fine tune these and add security, so we're not spilling data or answering data with information that the user otherwise wouldn't have access to.
One of the things we hear a lot about is this guardrails, right? Put in the guardrails, the security guardrails. Have someone, once they open the floodgates for use cases for AI, all of a sudden it's like, I have an idea, and I have an idea, and I have an idea. And most of the ideas are good, but can they be done, or can it be done safely, securely, and do they produce the other side of it? What are you starting to see agencies, okay, what's the first decision, or what's the kind of, not the first, but are they looking at the OCP side, right? Do we have the right hardware? Do we have the right software? Or are they looking at, they're trying to set the guardrails first and then worrying about the tail of it, which is the hardware and the such?
So what I'm seeing right now, a lot of the customers are feeling left behind, and they're saying, well, we need to have something, we need to be able to run these models and do some internal testing to define a use case, define the art of the possible. And so that's the first step, is getting the hardware, getting the gear to be able to run these models. Coming up with the use cases will come second. And then honestly, the security and fine tuning, that's a long process. That is going to require some oversight. There's going to be some policies coming out that may apply to how data can be used, what data can be used for train, and that sort of thing. But I think right now, to go back to your crawl, walk, run, you kind of have to do that in parallel. There are going to be employees that are ready to run, and there are going to be employees that might need some training to be able to leverage and use these LLMs or bots to increase their productivity.
What I'm seeing is a lot of the customers, we have an AI day where we come with NVIDIA and some of the choice vendors like Dell that the customer site is very familiar with. And then we do about a half-day training with them and say, hey, this is the art of the possible. And then we open it up to a forum, kind of similar to this, where we talk about what you guys want to do. And we get a lot of great feedback. The number one thing that we see, since we do a lot of data storage, is we want ChatGPT for our data.
Yeah.
And then the second thing I would say is they also want to see, hey, how can I automate a bunch of the sysadmin tasks that we've been doing? Like, hey, this is our policy. What are the tasks, the commands that I've run to orchestrate this before?
Yeah. And from an IT perspective, a lot of these sysadmins stare all day at these logs on the screen, and they're like, I can't make sense of this. And so that's probably a top use case from an IT perspective, is helping troubleshoot and look through logs and correlate data that otherwise would take a lot of manpower to be able to correlate those. That's been a top use case as well.
Man, a great anecdote or story is Los Alamos National Lab. They brought in OpenAI, and they took one of their largest supercomputers from classified to unclassified, and I think it was about 5-6 days, which is absolutely unheard of in the federal realm, just so they could do ChatGPT for their data, for their researchers. Because for the most part, you got to think about an aging workforce. How do I leverage all of the knowledge that we've built up for 50 years, 60 years, and how do we access it to the new folks?
The knowledge management piece is fascinating. It's an underappreciated piece of the federal sector that I think folks are starting to kind of come around for, as we see people leaving and folks the decrease in workforce. They have to, okay, how do we capture some of that information? How do we go back and say, okay, have we tried this before and did it work, and why or why not? Or how can we continue to evolve it? So I love your example of Los Alamos. I want to go back to the one thing, the data piece. That's always key when you talk about AI. Is the data ready? Is it? And most people's data, they'll say that's the hardest thing to do is get your data ready. When you talk to clients again, what's the piece that's stopping them? Is it being comfortable in their data, or is it just accepting that, don't let perfect be the enemy of good enough type of thoughts?
What I see is a lot of the folks don't leverage some of their traditional storage suppliers, APIs, and the way that they manage the data with the metadata. That's really it. It's how do you get the embeddings is the proper term to understand what that data is, who touched it, what is it relevant for, that sort of thing. So what we do is we go in and we just do an AI prep with the team to help them understand, okay, this data is ready, that data is not, this is the amount of effort it's going to take to get this ready.
I thought you were going to go down the blockchain for a second. I'm so glad you did it. Nothing against blockchain.
Buy Bitcoin.
Buy Bitcoin. Whole different discussion. We don't have enough time to talk about that. As we kind of look forward, agencies obviously still are trying to accelerate their use of AI. What are some of the big things they can do today? I think we hit upon some of them, the data, getting their data ready. I love the data prep piece. Are there other things that you're able to say, hey, here's other considerations as you're rolling out the AI and move to the OCP model?
Yeah, I mean, I think if they want to get started with AI today, they better give CTG a call. We can help them start. But beyond that, obviously you want to have the right hardware on-prem to be able to run those models. And then defining the use cases, and then also understanding your data, being able to tie the data to the use case and that sort of thing.
I'm going to interrupt real quick because I just want to go back to one thing. The hardware on-prem. We've been talking about cloud for 15 years, it feels like now.
Yeah.
And now all of a sudden, we have to have hardware on-prem. I thought everything was in the cloud. I know we talked about this earlier, but is that still a sticking point? Because agencies, so many got rid of so many data centers, are they having to upgrade their data centers so they can handle it? What is, I'm fascinated by, got to have it on-prem, but no, I have to be in the cloud. Now where do I go?
That's actually a good point. So at scale, when if you're talking, NVIDIA DGX boxes, the latest versions will run about 14 kilowatts for a single unit. So a lot of data centers are not prepared for that. They've got either low voltage lines coming in, or their PDUs don't have enough power to support that. So as part of the AI assessment that CTG does, we do come in, look at your facilities, see if you have enough power, cooling available, and the proper resources to connect all of the different pieces of the solution.
I think it's important to mention, like President Trump just did on the All In podcast this last week, talking about basically green lighting new power plants that you don't have to go off the grid and build these AI factories, because the power requirements is absolutely imperative if you're going to build something of scale on-prem. But to start off with, we've got the DGX Spark. It just looks like a Mac Mini, sits on your desk, can load some of the models, the open source models, and you can start testing today, and it's fairly inexpensive, $5,000-$6,000.
Yeah, and I wanted to mention the key reason why I say on-prem is your data may sit anywhere. It could be in the cloud, at the edge, in the data center. Moving that data from the edge or the data center to the cloud requires some bureaucratic oversight. That data may not be allowed or has a higher impact level than their cloud solution might offer, but repatriating data that sits in the cloud on-prem to using your AI models is an easy button. So it's kind of an accelerator to kickstart your AI. Is when you deploy it on-prem, you don't have any issues with the classification or security of that data.
Brad, we've got about a minute left or so in our conversation. I very much enjoyed it, and it's a fascinating look at where agencies can go and start thinking about what's coming next. When you look in the future, if we have this conversation a year from now, 5 years from now, what's AI infrastructure? What's the considerations? What are we looking at? Brad.
Yeah, I'm seeing quite a bit of power consumption, what's going on, everything. NVIDIA has committed to a 1-year, 12-month cycle to upgrade their processors, and the power densities are absolutely absurd. Even the hyperscalers are scrambling to try to take take advantage of it. So considerations around power, water cooling is going to be a very big factor. But what I see is the rise of LLMs within the federal government to do these chatbots, ChatGPT for your data, I like that term, makes it super relevant for folks. I see that as going to be an explosion, and then it's going to go to agentic, where multiple agents, they're going to be tuned on specific data sets, and then they can interact with each other.
Mm-hmm. Yeah, and I agree. I think the focus is all around power, and so on these chips, they're focusing on lower precision levels with the models, going from FP8 to FP4 now. I think we're going to see more die dedicated on the chips for FP4 processing of that data, just to speed it up, get it in smaller form factors, deliver some of that to the edge, I think is what we'll see.
My first computer was a 286. I'll admit that. My first PlayStation 1 was so if you use your T-shirt, now are we in the 286 world, and we're heading towards 486, and we're gonna, in terms of the chips, or are we even into Pentium? That was big.
I mean, we're at Pentium now and beyond.
We have time for this session of Workforce Reimagined. Let me thank my guest. Brad Baker is the co-founder and chief technology officer for CTG Federal, and Mosa Imam Jomeh, the executive director of engineering, also at CTG Federal. Thank you so much as well.
Thank you for having us.
I'm Jason Miller, and you're watching Federal News Network. Now let me send you back to the studio for more of Workforce Reimagined.